Now we know more indeterminate forms, but it always goes back to getting it into the form 0 over 0 or infinity over infinity so that we can use L'Hopital. So if I plug in 1, I get 1 over 0 minus ln of 1, you know, is 0, 1 over 0. So it's a fact that we use 1 over 0 as infinity. So this gives me infinity minus infinity, indeterminate form. So what is our process? We want to make a common denominator so we can make one fraction so that we can use L'Hopital's. So here we go. Limit as x goes to 1. So I'll get x ln of x minus x minus 1 all over that same denominator. So a lot of it is just a matter of just kind of cleaning it up. So I'm just going to take the time to rewrite this as x ln of x minus x plus a 1 all over, and I'm just going to multiply this out. So I get x ln of x minus ln of x. Okay, so let's check. Is it L'Hopital ready? If I plug in 1, ln of 1 is 0, and then I get a negative 1 plus a 1, that's a 0. ln of 1 is 0, 0. It's L'Hopital ready. Okay, I see product rule, so really careful, right? So let me pull it down here. Limit as x goes to 1. So first d second plus second d first minus 1, that's the derivative of negative x, all over first d second plus second d first minus a 1 over x. Wow, that's looking ugly. Okay, you can see these cancel, so that gives me a 1. So I'm just going to go slow here so you can see what I'm doing. So I get a 1 plus an ln of x minus a 1. Down here, I get a 1 plus an ln of x minus a 1 over x. Well, you look at that. Don't those 1's cancel? They do. So let's just rewrite it. So many times keeping your work organized will help you get to the correct answer. So now if I plug in 1, I get ln of 1 is 0. 1, ln of 1 is 0, minus 1. Oh, it's L'Hopital ready again. Let's do it. Limit as x goes to 1, 1 over x over. The derivative of 1 is 0. The derivative of ln of x is 1 over x. And then the derivative of this gives me a positive 1 over x squared. There it is. I can plug in 1. I get 1/2. And that's the answer. So then, since I've got room, I'm just going to go right here and do this one, and then I'll come back and do the tangent one. So if I plug in infinity, I get infinity times pi over infinity is 0. Infinity times 0. You know that's an indeterminate form. I need to put one of them in the denominator. Always move the easy one to the denominator. So in this case, it's x. So limit as x goes to infinity, so sine of pi over x, and I move x to the denominator as 1 over x, right? Just think of it as money. $10 is the same as 1 over $10, right? So that you know if it's money correct, then you know you've got it correct. So now let's go take the derivative as it is, because if I plug in infinity, I get 0 over 0. So let's take the derivative. So I get cosine of pi over x. And if you want to make sure you're taking the derivative of pi over x correctly, let's go slow. So this is pi x to the negative 1. So that's negative pi x to the negative 2. So that's what I'm going to write here. Negative pi x to the negative 2. And then, what's the derivative of 1 over x? So again, the derivative of 1 over x is the same as x to the negative 1. So that's negative x to the negative 2. Oh, will you look at that? There's a lot of canceling happening there. So let me just use some colors here. So I see a negative in common between the numerator and the denominator, right? This negative. And, oops, I wrote this down wrong. It's x to the negative 2, right? Sorry about that. So it's x to the negative 2. So the x to the negative 2's cancel. So what am I left with? Limit as x goes to infinity. I'd have this number pi carrying along. cosine of pi over x, because these other things would cancel. Now if I put in infinity, cosine of 0 is 1, I get pi as the answer. And again, let me just do these out of order. So here I have, if I put in 0, I get sine of 0, which is 0, ln of 0, which is infinity. Okay, I have a whole section about how you don't put the ln in the denominator. So let's rewrite this. And the 0 from the positives, just making sure that the ln exists. So keep the ln here. And then we don't want to write 1 over sine. We want to write it as cosecant, because I don't want to have to do quotient rule. That would be horrible. Okay, here we go. So 1 over x over the derivative of cosecant is negative cosecant cotangent. That's really ugly. Do not go take the derivative again like this. You must simplify it. You will get stuck in an infinite L'Hopital loop. So I'm just going to take the time. So 1 over x over, let's write each of these as the fractions that they are. 1 over sine of x, and this is cosine of x over sine of x. So let's multiply by the reciprocal. So I get a 1 over x. And then carry this negative out here, then it would be sine squared over a cosine. Okay, well, now what happens when I plug in 0? I get 0 over 0 again. So let's just one more time, I think. So I get a negative, you're doing chain rule, 2 sine of x times cosine of x over, and down here you see product rule. First d second plus second d first. Now what happens when I plug in 0? If I plug in 0, the whole numerator equals 0. What about the denominator? That's 0. That's 1. 0 over 1 is 0.